Check if rational functions are inverses. Rational functions versus just identifying inverse functions, same process. It's just that the solving for the inverse actually comes a little more complicated than just a regular one. You can see over on the left side how simple it is to just swap x and y and then solve. It makes sense. You just solve for y equals all over again. The process is the same for rational functions, but there's a lot more steps and there's more explanation involved in how to get that to the way we want it. So let's go ahead and just take a look. I'm going to choose the first function. Now, we always have two options. We can take the longest route possible, which is we could sub f of x in for g of x, simplify that, find out what it equals. We could sub g of x in for f of x, solve that, see what it equals. If they are both the same output or equal the same thing, then we know that they're inverses of each other. If we want to take a shorter route, we can just choose one of these functions, swap our x and y, and then start solving for y all over again. So this process is going to be a demonstration of going through swapping the x's and y's just as we would for a normal function that's not a rational function. So I'm going to go ahead and rewrite this where x and y is swapped. So it's going to be x equals negative y minus 3, negative 3y minus 3. Okay, so whenever we're dividing something by negative 3y minus 3, it's implied that these are all grouped. Anytime we want to do the inverse, all we do is do the actual inverse of what we're trying to do. So if we don't want to divide by negative 3y minus 3, we just multiply both sides by negative 3y minus 3. This would be undoing what's being done. Now, whenever we say it's undoing, okay, we're no longer dividing by, so now these can go away and we're left with negative y minus 3. We also need to distribute the x to the negative 3y and the negative 3. So that would be negative 3xy minus 3x equals negative y minus 3. Now here's where some swapping takes place because we're trying to solve for y. We're trying to isolate it. Now, whenever we are doing this swapping, the whole point is to isolate y. And the way we're going to be able to do that with that xy over on the left is move all of our y's over to the left so we can factor it out of the left side. And then we'll have all of our x's over on the right side after we do the division. So let me show you what this looks like. What you could do is like a double switch. I like to do one step at a time. So I would do plus y, then rewrite the whole problem. 3xy plus y minus 3x equals negative 3. Then I would move the 3x. I like to see each step as an individual thing. And, like you could cancel them out, wherever you're seeing the zero pair. I like to see each step as it's being done. That way, if I make a mistake, I can go back and start analyzing my work all over again. Whenever we're showing each step, it makes it easier for error analysis. So you can see over here on the left side, whoa, we have negative 3xy plus y. Man, that looks complicated. But at the same time, is there something that both of those terms have in common? And the answer is yes. They both have y in common, which means that we can factor it out. So that means if we take a y out of both of those terms, that's going to leave us with negative 3x plus 1. And that's going to equal the left side equals 3x minus 3. So you can see how that took place, and that's not really that big of a deal, but that's the intent behind the whole swap, is so we can factor out that y so then we can have y by itself, y equals. Well, I see that y is being multiplied by negative 3x plus 1. I don't want that there. I want that y by itself. So if I know I'm multiplying by it, I can do its inverse, and I can divide by that entire quantity on both sides. So you can see this is where we're going to create 1 that equals 1, and we're left with y equals 3x minus 3 over negative 3x plus 1. And here's where you're going like, okay, fine, we found the inverse. How am I supposed to know if it's the inverse of what I was looking for? Well, whenever we do this, you can see that this right here is the other function. So once we've gone through that process and we solve and we find the inverse of the function we chose, we compare it to the other function. If it's its inverse, cool, then we found the inverse. If it's not the inverse, then we'd say, no, the two functions are not inverse of each other. So the answer to this one would be yes. So let's go ahead and take a look at another one. And I'm going to choose f of x again, because why not? I'm going to rewrite it. Y equals negative 3x plus 3 over 4x plus 1. Then I'm going to rewrite it with the variables swapped, and we're going to follow the same process. Okay, so we can see I don't want that divided by 4y plus 1, right? I want to get rid of that. So I'm going to do its inverse times 4y plus 1. I'm going to do that to both sides, 4y plus 1. Once I do that, I'm able to go, okay, well, those are creating 1, and that leaves me with negative 3y plus 3 over on the right side. Now I need to distribute that x to the 4y and the 1. So 4xy plus x equals negative 3y plus 3. So you can see, yet again, we have a y on the right side, and we have a y on the left side. We also have x on the left side. Oh, it's just so much. But keep in mind, what we're trying to do is get y by itself. So what we're going to do is we're going to swap those x and y terms to where the negative 3y is going to be positive 3y on the left. We're going to get rid of that positive x by making it a negative x on the other side. Then we're going to be able to factor out that y. So plus 3y plus 3y. Again, I'm just going to write out every step. Plus 3y plus x equals 3. Now let's get that x over to the other side. Minus x. And we have 4xy plus 3y equals negative x plus 3. All right, so you see a whole bunch of complicated stuff on the left, but this is exactly where we have that opportunity to factor out the y. We're looking at both terms on the left, and we're saying, what do they have in common? Well, we can see that they both have a y, so I'm going to extract that from the left side. 4x plus 3 equals negative x plus 3. So what you're seeing here is I've got something being multiplied on the left side. You can see it almost replicates exactly what the previous example was, but now we still have to take the same approach. Well, I don't want y to be multiplied by 4x plus 3, so I'm going to do its inverse to get rid of it. So I'm going to divide by 4x plus 3. That's going to create 1. And then I'm going to divide the other side, because that's what I have to do when I'm balancing equations. So now we have y equals negative x plus 3 over 4x plus 3. Now we're back to the same spot again. Is this the same as the other function that was given? And the answer to that's no. So these are not inverse of each other.